1 minute ago, another earthquake rattled the streets of Pozzuoli. Residents felt the familiar jolt, then the low rumble that follows. Some checked their walls for new cracks. Others simply waited for it to pass. This has become routine in a city built atop a restless supervolcano. But beneath the surface, something has changed. New fault structures have been mapped. Steam vents are multiplying, and scientists are now asking a question that once seemed impossible. Could the unrest at Campi Flegrei somehow connect to Mount Vesuvius, just 9 kilometers away? If these two volcanic systems shared deep connections, what would it mean for the 3 million people living between them? What do the latest scientific findings reveal, and why are some researchers now treating both giants as parts of a single, interconnected threat? The answers may determine the fate of more than 3 million people, but this was only the first warning. Campi Flegrei does not announce itself with a towering cone or a plume of smoke. It hides in plain sight. The caldera sprawls beneath neighborhoods, schools, ancient Roman ruins, and the busy port of Pozzuoli. Its rim is so gentle that most residents barely notice they live inside a volcanic crater. The scale is staggering. The caldera measures roughly 13 kilometers across, larger than the island of Manhattan. More than 500,000 people live directly atop this hidden giant. Beyond them, the greater Naples metropolitan area houses over 3 million residents within reach of its power. The Vesuvius Observatory, operated by the Istituto Nazionale di Geofisica e Vulcanologia, monitors every tremor and gas release. Since 2005, the ground beneath Pozzuoli has risen relentlessly. By mid-2025, cumulative uplift at Rione Terra reached 148 centimeters. The Earth is breathing, swelling outward at rates not seen since the crisis of the 1980s. And the signs were already spreading. For decades, geologists believed Campi Flegrei and Vesuvius operated as separate systems. The two volcanoes sit only 9 kilometers apart, yet their magma chambers were thought to be isolated. Sealed conduits and ancient rock barriers supposedly kept them independent. That assumption is now under scrutiny. Satellite radar data analyzed between 1992 and 2008 revealed something unexpected. Episodes of deformation at both volcanoes appeared to occur in correlation. When Campi Flegrei inflated, Vesuvius showed what could be sympathetic movement. The pattern was subtle, and researchers cautioned that correlation does not prove causation. Still, the findings prompted new questions about deeper connections. Tomographic surveys had detected a magmatic body at roughly 8 kilometers depth that appears to extend across much of the Neapolitan volcanic district. If this layer truly links the two systems, pressure changes at one volcano could, in theory, propagate to the other. Some scientists suggest that future unrest might open physical pathways through what was once solid rock. This remains speculative, but the possibility has elevated the urgency of monitoring both systems together. What came next shocked even the scientists. The ground beneath Naples has been rising and falling for millennia. The Romans documented this phenomenon at the Temple of Serapis in Pozzuoli, where marine borings on marble columns record ancient sea levels. They called it bradycism, from the Greek words for slow movement. But the current episode is anything but slow. Since 2018, ground uplift has accelerated dramatically. The rate at the RITE monitoring station in central Pozzuoli reached 2 centimeters per month by 2024. From January 2024 through mid-2025, the ground rose approximately 30 centimeters. This pace matches or exceeds the infamous crisis of 1982 to 1984, when 40,000 residents were evacuated. The difference now is what lies beneath. Researchers at Stanford University partnered with Italian scientists to apply machine learning to seismic data from January 2022 to March 2025. The artificial intelligence detected tremors that human analysts had missed. The standard catalog listed roughly 12,000 earthquakes during this period. The AI expanded that number to more than 54,000. The pattern that emerged was stunning. The earthquakes traced a sharply defined ring structure encircling the caldera. This ring fault system had never been seen so clearly before. But the ground had one more secret. On March 13, 2025, at 01:25 local time, a magnitude 4.4 earthquake struck the caldera. The event ruptured along the coast of the Gulf of Pozzuoli, near the densely populated Bagnoli district. The shaking was felt across the entire Naples metropolitan area. This matched the largest magnitude recorded during the current unrest phase. It came during a swarm that produced hundreds of smaller events in the surrounding hours. By mid-2025, subsequent earthquakes had reached magnitude 4.6, continuing the pattern of escalating seismicity. The quakes are shallow, typically less than 3 kilometers deep. At these depths, even moderate magnitudes produce intense ground shaking. Residents have reported cracks appearing in walls, objects falling from shelves, and a deep rumbling that seems to come from everywhere at once. Scientists examining the data found something else. The ring fault system was not simply cracking under pressure, it was reactivating along ancient fractures that had formed during catastrophic eruptions tens of thousands of years ago. The hidden structure was waking up. To understand what threatens Naples today, one must travel back 39,000 years. The Campanian ignimbrite eruption remains the largest volcanic event in Europe in the past 200,000 years. When the ancient caldera emptied its magma chamber, it ejected between 250 and 300 cubic kilometers of material. Ash blanketed an area of 3 million square kilometers, reaching as far as the Russian plains. The eruption collapsed the ground above the emptied chamber, creating the caldera that now holds the modern city. Temperatures dropped across the northern hemisphere by 1 to 2 degrees Celsius. Some researchers link this event to the decline of Neanderthal populations in Europe. 15,000 years later, another massive eruption carved the Neapolitan yellow tuff. This event excavated the caldera further and deposited thick layers of volcanic material across the region. Together, these two catastrophes established Campi Flegrei as one of the most dangerous volcanic systems on Earth. And then it went quiet, but not dormant. Since the Neapolitan yellow tuff eruption, at least 70 smaller eruptions have pierced the caldera floor. The most recent, in 1538, built the hill called Monte Nuovo in just a few days. Contemporary accounts describe ground uplift of up to 7 meters in the years preceding the eruption. Villages were abandoned as the earth swelled and cracked. The current unrest has not yet reached those extremes, but the trajectory is unmistakable. Beneath the surface, Campi Flegrei operates like a massive pressure vessel. Magma sits at depths of 3 to 8 kilometers, releasing gases that accumulate in a shallower hydrothermal reservoir. This reservoir acts as a buffer between the deep magma and the surface. When gas pressure builds, it pushes the overlying rock upward. The ground inflates, faults slip and crack. Earthquakes rattle the caldera. Eventually, the pressure finds release through fumaroles, vents where steam and volcanic gases escape. The Solfatara Piciarelli area hosts the most active vents in the caldera. Here, the smell of sulfur hangs in the air. Mud pools bubble continuously. Steam hisses from cracks in the ground. Recent measurements show alarming changes at these vents. Carbon dioxide emissions from the Piciarelli fumarole have increased dramatically since 2012. By 2019, the main vent was releasing over 600 tons of CO2 per day, comparable to emissions from medium-sized erupting volcanoes. More recent measurements through 2024 showed total emissions from the Solfatara Piciarelli system reaching approximately 4,000 tons per day from fumaroles alone, with additional thousands of tons from diffuse soil degassing. Vent temperatures have climbed to 114 degrees Celsius. Surrounding soils exceed 50 degrees in places. The gas is not merely escaping, it is pressurizing the system from below. And the pattern was accelerating. In the narrow streets of the Rione Terra district, families have learned to live with the volcano's moods. Residents describe waking each morning and checking their walls for new cracks. Plaster near windows develops webs of fractures that grow wider with each passing month. At night, some feel the floor vibrate, a deep pulse that seems to rise from the earth itself. Neighbors share similar stories. Doors that once closed easily now stick in their frames. Hairline fractures have appeared in buildings that survived the 1980s crisis without damage. The air in certain basements carries a faint metallic tang, a reminder of the gases seeping from below. Civil protection officials have installed monitoring equipment throughout the neighborhood. Sensors track ground movement, gas concentrations, and seismic tremors. Warning signs posted on street corners explain evacuation routes. Residents have participated in drills, loading into buses that would carry them to designated assembly points. But the drills assume warning time that may not exist. The official evacuation plan for Campi Flegrei estimates 72 hours to move approximately 500,000 people from the red zone. The plan requires 12 hours for organization, 48 hours for transport, and a 12-hour safety margin. Each municipality in the danger zone has been twinned with a region elsewhere in Italy that would receive evacuees. The challenge is knowing when to start.
The connection between the ring fault reactivation and broader volcanic processes remains a subject of intense study. Scientists at the INGV have identified very long-period seismic signals originating at depths of approximately 3.6 kilometers. These signals suggest resonance within gas-filled fractures connecting the deep magma reservoir to the shallow hydrothermal system. The fractures appear to be conduits. They channel pressure and fluids upward through the crust. When the pressure exceeds the strength of the surrounding rock, earthquakes occur. When gas reaches the surface, fumarole activity intensifies. The mapped fault structures could accommodate ruptures up to magnitude 5.1. An earthquake of this size at shallow depth would cause significant damage to buildings throughout Pozzuoli and the surrounding area. Some structures, particularly older construction, might collapse. But the seismic hazard may not be the greatest threat. Scientists describe two possible futures for the current unrest. In one scenario, the system continues its current pattern of inflation and seismicity for months or years before eventually subsiding. This happened after the 1982-1984 crisis, when the ground deflated and activity declined. The volcano returned to a lower baseline, though it never became truly quiet. In the other scenario, the unrest escalates toward eruption. The signals that would precede such an event remain uncertain. Magma might begin migrating upward, triggering new patterns of seismicity and deformation. Gas emissions could surge dramatically. The hydrothermal system might destabilize, producing phreatic explosions even without magma reaching the surface. Current monitoring shows no direct evidence of magma ascending toward the surface. The AI-enhanced seismic analysis detected earthquakes only at depths above 3.7 kilometers within the ring fault system. Deeper activity, which might indicate rising magma, has not been observed. But scientists emphasize that absence of evidence is not evidence of absence. The question that haunts emergency planners extends beyond Campi Flegrei itself. If the caldera were to erupt, what might happen at Vesuvius? The evidence for connection between the two systems remains circumstantial and debated among scientists. The correlated deformation episodes detected by satellite suggest a possible link. The shared deep magmatic layer revealed by seismic tomography could provide a mechanism. The chemical similarities between volcanic products from both systems hint at common origins. Based on these observations, some researchers hypothesize that a major eruption at Campi Flegrei could release enormous quantities of gas and pressure. If that release propagated along subsurface pathways toward Vesuvius, it might, in theory, destabilize a system that has been building pressure since its last eruption in 1944. This scenario remains unproven, but it has prompted calls for unified monitoring. Vesuvius has its own red zone, encompassing 25 municipalities with 700,000 residents. The combined population at risk from both volcanic systems exceeds 3 million people. No evacuation plan currently addresses simultaneous unrest at both sites, though some experts argue such planning has become necessary.
The possibility of linked volcanic behavior once seemed remote, but as new data reveal potential connections between the systems, emergency planners face difficult questions about scenarios that may have no historical precedent. The consequences of a major eruption would extend far beyond the Naples metropolitan area. Ash from the Campanian ignimbrite reached Eastern Europe. A similar event today would ground aviation across the continent, contaminate agricultural land throughout southern Italy, and create a respiratory health emergency affecting millions. Economic disruptions would cascade across supply chains. Italy's third largest city would be evacuated or destroyed. Recovery would take decades. Global volcanologists have converged on the region. Research teams from Stanford, the University of Geneva, and institutions across Europe are collaborating with Italian scientists. New monitoring equipment has been deployed. Emergency protocols have been updated. But the volcano operates on its own timeline. The current phase of unrest at Campi Flegrei represents the most significant activity since the 1538 eruption of Monte Nuovo. The ground has risen nearly 1.5 meters since 2005. Earthquake magnitudes have reached levels unprecedented in the instrumental record. Gas emissions have surged to rates typically associated with active volcanism. Scientists cannot predict whether this unrest will lead to eruption. The historical record provides limited guidance for systems that have been quiet for centuries. The relationship between Campi Flegrei and Vesuvius remains poorly understood. The newly discovered ring fault system adds another variable to an already complex equation. What the data reveal is a caldera under increasing strain. The ring fault is active. The hydrothermal system is pressurizing. The conduits connecting deep magma to surface vents are open and channeling gas. The residents of Pozzuoli check their walls for cracks and wait for the next advisory. The sensors record every tremor and temperature spike. The evacuation plans sit ready, untested at full scale. And beneath the streets, where newly mapped faults trace paths across the caldera, the Earth continues to breathe. The question is no longer whether something is happening beneath Naples. The question is what comes next. Whether the current crisis remains a prolonged emergency or escalates into catastrophe depends on processes occurring kilometers underground, beyond the reach of any intervention. Scientists watch, residents wait, and two volcanic giants, separated by just 9 kilometers, may share deeper connections than anyone realized. If you want to stay informed as this situation develops, consider subscribing. The story of Campi Flegrei is still being written, and the next chapter could arrive without warning.